Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this June 2025 lecture series, we are going to discuss about PN junction diode in electric circuits and electron devices. What do you mean by PN junction diode? What is P? What is N? See here, a pure silicon crystal or germanium crystal is known as intrinsic semiconductor. There are not enough free electrons and holes in an intrinsic semiconductor to produce a usable current. So here an electrical action which is used to modify the intrinsic semiconductor, which is called as doping. Here in this doping, after a crystal is doped, the semiconductor is called as extrinsic semiconductor. Here we have two types. One is N-type semiconductor and another one is P-type semiconductor. N-type semiconductor, it having free electrons as majority carriers. We know that. P-type semiconductor having free holes as majority carriers. Here, if a junction made by joining both P-type as well as N-type semiconductor and make it as a useful device called diode, and it allows the current to flow from only in one direction. An intrinsic semiconductor is modified by extrinsic with the help of doping. In this doping, we have N-type as well as P-type. See the diagram. See here, in this PN junction, we have P-type material, N-type material. By joining both P and N-type, we will get PN junction. Here in P-type material, holes are majority carriers, N-type electrons are majority carriers. See here, by combining both P and N-type, we can make it a useful device which is called as diode. See here, diode allows the current to flow in one direction. The very basic element is a diode. See, in PN junction, holes from the P side diffuse into N side where they recombine with free electrons, and free electrons from N side diffuse into P side where they recombine with free holes. The diffusion of electrons and holes is due to the fact that a large number of electrons are concentrated in one area and large number of holes are concentrated in another area. When these electrons and holes begin to diffuse across the junction, they can collide with each other, and negative charge in the electron cancels the positive charge of the hole, and both hole as well as electron will lose their charges. This diffusion of holes and electrons in electric current, it is referred as a recombination. This recombination process and decay it exponentially with both time and distance from the junction, and this recombination normally occurs when the PN junction is made after the recombination. The junction is made and very near to junction. That time recombination occurred. See the diagram. In this PN junction, we have middle layer depletion region. What is the depletion region? The electrically charged atoms are called ions since they are no longer neutral. After several collisions occur, electric field is great enough to repel a rest of majority carriers away the junction. Here, this region immediately produces the surrounding region that has no majority carriers. This junction is known as this is called as barrier or depletion region. This physical width of the depletion region depends on the doping level. If doping is higher, the depletion region is high. If doping is low, we have less depletion region. See in PN junction diode, we have anode as well as cathode. A semiconductor diode is a two-terminal device, electronic component with a PN junction, which is also called as a rectifier. Here we have A and K, anode and cathode. Here anode, which is a positive terminal of the diode, and cathode is negative one. See the symbol A, K, A is plus, K is minus. See here, biasing of diode, forward bias condition. We have two biasing, one is forward, another one is a reverse. In forward bias condition, we connect the positive side of anode with positive of our source. See here, see the second one. Here we have electron flow from P to positive side of the source, which is measured in milliamps, and again the flow is continued to N region. The flow is continued. PN junction forward biasing. See the diagram from P to N. See, biasing of diode, reverse biased condition. See, here we have one change. Our positive anode is connected with negative of the source. See the diagram. Here, with external field, we'll get a graph like this. No external field, will get a moderate amount of signal output. See, in reverse bias condition, we have not that much current flow. Literally, there is no current flow in ideal, but somewhat we have little bit amount of current flow, but it is not not that much high when compared to forward biasing. See, here we consider the peak inverse voltage. It can be defined as the maximum reverse voltage that a diode can withstand without being destroyed is called peak inverse voltage. See here, we have applications in forward biasing and also reverse biasing. Based on the application, we can choose either forward or reverse biasing. Next one is RV characteristics of the diode. See our diode is connected with a resistor, source and voltmeter, ammeter. See here the graph. Forward voltage, a reverse voltage. The graph is high when voltage increases, current also increases in forward biasing condition. And in reverse voltage, after breakdown voltage, the current will decrease simultaneously. Thank you. I think I will get a clear understanding about BJT as well as PN junction diode and our electric circuits and electron devices. Thank you.